Hi, hairs. So here we go again. Another starter. What I want you to do is, can you name this molecule? Now remember, there's two hydroxyl groups. So remember how we name more than one hydroxyl group. I want you to draw 2,3-dimethyl butanoic acid. And this one here, I want you to explain why methanol has a higher boiling point than ethane. Okay, so I've started you off. I've got methanol on the left and I've got ethane on the right for you. Okay, so pause this video and then attempt it. I'm just about to go over the answers just now. Right, so this one here, we need to obviously identify the hydroxyl groups, which we've kind of already done. So the OH is there, and we start from the side closest, so that would be the right. So that's carbon 1, 2, 3, 4 and carbon 5. Right, now we also have a branch on carbon 2. So let's start. We'll name the alcohol part first. So there's 5, so that's pent, and we've got a functional group on carbon 1 and carbon 4. Okay, so that would be pentan 1, 4, and because there's 2 of them, that's diol. So pentan 1, 4, diol, and the branches on carbon 2, so that would be 2-methyl pentan 1, 4 diol. Okay, right, draw 2,3-dimethyl butanoic acid. So we're drawing a carboxyl group, so draw our longest chain, which is 4, because, well, it's but. So that's 1, 2, 3, 4. Draw the carboxyl group, which is C double bond O OH, and then carbon 1 is always sort of from the functional groups. That's 1, 2, 3, 4. So we draw a branch on carbon 2, and we draw a branch on carbon 3. Doesn't matter whether you've got it on the bottom or the top or bottom, or both on the same side, both top, both bottom, as long as you've got the correct branches and you've got the correct number of hydrogens. Okay, so you should be getting those two. If you're not, just look over the previous video, make sure you have a full understanding. Now this one here, explain why methanol has a higher boiling point than ethane. Now remember what I said when we did bonding, what feels like years ago. It's got a functional group, so you have to name that functional group. Okay, so we would write contains hydroxyl group. Okay, so that's so important that you're naming that functional group. So it contains the hydroxyl group, and let's do our sort of checks. So we've got the electronegativity, so we've got O is 3.5, H 2.2, so our difference equals 1.3. So we've got polar bonds like that. Okay, now we know, because it's not a tetrahedral shape, we know instantly it's asymmetrical. Asymmetrical, therefore polar molecule. Okay, and because it contains that hydroxyl group, it contains the H covalently bonded to the O, it contains hydrogen bonding. Okay, and of course it also contains LDFs, because everything contains LDFs. Now this one here, again, there's no functional group, so we don't need to write that. So our first check is electronegativity. C, you should know these off by heart now. So the difference is 0.3. So that means it's non-polar bonds. And because it's non-polar bonds, we don't even need to go into step 2. That just makes it a non-polar molecule. Okay, and if it's non-polar, it contains LDFs only. Yeah? Now, we've spoke about one molecule, we've spoke about the other molecule. Now we need to do is compare them. Okay? So again, this one contains hydrogen bonding, this one doesn't. So you need to know the difference in strength, and you should know hydrogen bonding, although it's still a weak force, hydrogen bonding is still stronger than LDFs. Therefore, methanol has a higher boiling point. Okay, and that's it. That's all you have to write. Just make sure, remember, you're mentioning the functional group. Okay, now that we're on to Unit 2, we're going to be looking a lot more at different functional groups, so just make sure you are mentioning them. Now, I could have asked, part B is, why are we able to compare methanol and ethane? Now, if you work out the GFM, you'll work out that methanol has a GFM of 32 and ethane has a GFM of 30. So the reason we can compare these two is because they've got a similar GFM, but you need to expand that just a wee bit further. It's not good, just good enough to say they've got a similar GFM. Because they've got a similar GFM, they've got a similar number of electrons, therefore they've got a similar sort of strength in LDFs. Okay, so the LDFs in each one are of similar strength, so the only thing that's different is that this one's got hydrogen bonding, and that's why we're able to compare. Okay? Right. So we're still in Unit 2, obviously. We'll be in Unit 2 for a while. We are going to look at the types of alcohol. Okay, so as usual, just you guys write what I'm writing, and then I'll put up some questions on Teams. So, let's just start again. Alcohols can be classified into 3 types of just hold it there. So alcohol can be classified into 3 types. Okay, the 3 types are primary, secondary, and a new word that you've probably not came across, tertiary. Okay, so we've got primary alcohols, we've got secondary alcohols, and we've got tertiary alcohols. Okay, and it's all linked into the position of this functional group, of the hydroxyl group. So we're going to start on primary alcohols. Okay, the definition of a primary alcohol is when the carbon attached to the hydroxyl group, OH, so when the carbon attached to the hydroxyl group is attached to only one other carbon. Okay, so what I mean by that, if we draw propan 1O, like so, okay, what we need to do is we locate the functional group, and then the carbon, let me just draw a different pen, the carbon that's attached to that functional group is only attached to one other carbon. Okay, that's what we mean by a primary alcohol. So when the carbon attached to the functional group is attached to only one other carbon. Okay, so that's propan 1O. Now, let's go to secondary alcohols. Now you might already be able to guess the definition of this, but let's go for it. So when the carbon attached to the hydroxyl group, I'll just move that in so you can see it. So when the carbon attached to the hydroxyl group is attached to two other carbons. Okay, and if we just take an isomer of the alcohol above and we go for propan 2O, okay, let me just name this. Again, if we locate our functional group, okay, and then we focus on the carbon that's attached to that functional group, that carbon is attached to two other carbons. Okay, so we're interested in the carbon that's attached to the hydroxyl group, and then depending on how many carbons that carbon's attached to determines whether it's primary, secondary or tertiary. Okay, so carbon attached to the functional groups attached to two carbons, so this is a secondary alcohol. Now, a tertiary alcohol, you know, no real prizes if you can work out the definition for this. But a tertiary alcohol is when the carbon attached to the hydroxyl group, again I'll just move that in. So when the carbon attached to the hydroxyl group is attached to three other carbons. Okay, so let's just go for let's go for methyl propan 2O. Okay, now you can call this methyl propan 2O or you can call it 2-methyl propan 2O. The reason that you don't need the 2 is because there's no other place that branch can go. Yeah, because if it goes there, the longest chain is just 4. Okay, so either 2-methyl propan 2O or methyl propan 2O. Now, again, look for the hydroxyl group and then focus on that carbon that it's attached to. Okay? Now, the carbon that's attached to the hydroxyl group is attached to 1, 2, 3 carbons. Okay? And that there is what makes it a tertiary alcohol. Okay? So we've got 3 definitions, 3 brand new definitions. However, they are quite easy to learn because the minute you've got one of them,